Welcome to this edition of Take 5 with Tony. Today we're going to talk about a big, daunting problem, climate change. Now, what does that have to do with butternut squash? You'll find out. But let's start by a quick review. Climate change, we all hear about it, we know about it. Fundamentally, climate change has resulted from the fact that we have too much carbon up there in the atmosphere, from carbon dioxide, methane, and other sources. That carbon in the atmosphere, as we now know, is leading to trapping energy below the atmosphere and here on Earth. And that energy, that stored energy, means excess heat. 2014, hottest year ever. 2015 projected to be hotter still. But also things like more storm activity and more irregular weather. So places like California get mega droughts and other places get horrific rainstorms. All that irregularity and the heat in part attributable to climate change. Now we know that there's a lot of things we have to do to change it. I mean, we live in big homes, we like them toasty warm in the winter and cool in the summer. And we know we have to make some changes there and in our transportation habits, favoring mass transit and walking over just constant automobile traffic. But while we're aware of all that, there's a solution that often gets missed that's part of our response to climate change. We have too much carbon up there in the atmosphere, but we don't have enough down here in our soil. You see, carbon is a fundamental building block of soil organic matter. And soil organic matter is so cool. It is the thing that allows us to store fertility, provide to the plants, grasses, and other things that the animals eat. It helps us make our vegetables and grains more nutritious. And very importantly, it provides relief to farmers and crops in times of stress, especially drought, because it holds water. Organic matter is so important that in our short time on this farm, we've built it up from less than 2% when we started here to over 5%, more than doubling the organic matter. And that's made a huge difference in our farming and in the nutrition content of our vegetables. Now, farmers all over the world are looking at ways to build organic matter, and we're going to look at one that relates to the butternut squash. Because we know that worldwide, our soils have lost between 50 and 70% of their soil carbon. One experiment we did this year was in Tom's butternut patch. Tom is a friend and fellow farmer who was working some of our ground this year. He planted a field of butternut here. He's harvested the butternut. Normally, in a vining crop like butternut and pumpkins, farmers would plant the plants and soon thereafter spray herbicide, and then come back a few weeks later and spray herbicide again to control the weeds. Organic farmers don't spray herbicide, but they would likely till and till again and till again, and all that tillage, well, it's not great for the soil structure and it's bad for the carbon balance because it releases carbon to the atmosphere. What we did here instead was, after just one tillage, we planted cowpeas, this vigorous legume, and these cowpeas have done multiple things. They've virtually smothered all the weeds that we would normally see this time of year. They have added nitrogen to the soil here for next year's crop, and they've helped create the soil biology and root systems that will pull carbon from where we have too much in the atmosphere to where we don't have enough in our soils. A simple solution. This is one of many kind of practices that farmers are using on produce farms, on organic grain farms, and farmers using ranching practices to restore the health of the soil. The Rodale Institute recently estimated that if all cropland in the U.S. switched to low-till organic practices, it would be the equivalent of taking nearly 200 million cars off the road in terms of our carbon balance. There's a lot we can do, and it's not the whole answer, but how we eat and which kinds of farming we support is a big part of our response to climate change. Thanks, and see you next time.